Hi, my name is Sruthi Sudhakar and I'm from Georgia Tech. I worked alongside Viraj Prabhu, Arvind Krishnakumar, and Dr. Judy Hoffman to study mitigating biases in visual transformers via targeted alignment. Deep learning-based computer vision has been advancing rapidly and is being deployed in high-stakes applications. While one may think that a well-trained model that exhibits high accuracy rates overall should be readily deployed in the real world, recent studies have shown that deep models often take advantage of spurious correlations between attributes in the data when learning to make predictions. These unintended correlations can cause the model to act in a biased way, such as having lower accuracy on certain subpopulations of the data. While many have studied the fairness of computer vision tasks learned using CNNs, the fairness implications of the newly introduced visual transformers are yet to be studied. We performed the first fairness assessment of visual transformer models and benchmarked several existing bias mitigation algorithms. To understand where the bias is encoded, we visualize the feature space of the visual transformer. Then we introduced TDET, Targeted Alignment for Debiasing Transformers, a novel debiasing algorithm. To evaluate our method, we use the task of single-label attribute prediction on the Celeb dataset, while requiring invariance to a defined protected attribute. We measure the performance of our method using balanced accuracy and standard accuracy, and the fairness of our method using equalized odds and balanced accuracy difference. The visual transformer contains a naturally separated and spatially cohesive feature space. We trained a visual transformer for a certain task such as smiling, and visualized the query and key matrices to gain some insight into the feature encodings. We hypothesized that in a totally unbiased model, there should be no understanding of the protected attribute, and therefore no discrepancies across this attribute. However, as seen in this figure, there is a large difference in the query matrix activations within a smiling across the protected attribute of high cheekbones, while the key matrices look fairly similar. This result is also observed in the case of not smiling. This observation of a large difference in query matrix activations motivates our focus on alignment of query activations for debiasing. So we use this idea and propose our bias mitigation algorithm TDET. TDET considers a visual transformer model trained using a standard task loss and performs debiasing through the introduction of two class-specific alignment losses. First, the adversarial loss is computed on the query class token. Second, the L2 loss is computed on the entire query matrix apart from the class token. Additionally, we benchmark previous mitigation approaches on the transformer, including MMD, DAN, laughter, and domain-independent training. We find that TDET consistently improves fairness in both equalized odds and balanced accuracy difference, while maintaining performance in balanced accuracy and standard accuracy compared to the original transformer model. TDET achieves best or second best in 11 out of the 12 settings compared to all previous debiasing approaches. Within a test setting, there may be other debiasing methods which produce stronger debiasing results according to a single fairness metric, such as laughter on the wavy hair wearing lipstick setting. But we note that across settings and considering all metrics, our method consistently performs comparably or better than prior work. We further note that while domain-independent training provides the strongest equalized odds performance, this approach does not produce strong balanced accuracy difference or balanced accuracy and standard accuracy performance, likely due to the imbalanced task data for the underrepresented protected attribute. Finally, we visualize the new values of the average query and key activations. The query activations look very similar across settings of the protected attribute. These results, combined with our improved fairness results with TDET, validates our hypothesis that targeted debiasing focused on the query activations is an effective debiasing strategy for visual transformers. Overall, we performed the first benchmarking of several existing debiasing algorithms on visual transformers and use this information to introduce TDET, a targeted debiasing algorithm for transformers that aims to remove discovered biases encoded within the query matrices. Thank you.